When transitioning from old to new wiring during a remodel, several key factors need careful consideration to ensure a safe and code-compliant electrical system. Improper transitions can lead to hazards, code violations, and potential long-term problems. Firstly, always de-energize the circuit before working on any electrical wiring. This is a fundamental safety precaution that cannot be overstated. Use a reliable voltage tester to verify that the power is off. Secondly, assess the condition of the existing wiring. Look for signs of damage such as frayed insulation, corroded conductors, or improper connections. If the existing wiring is in poor condition, consider replacing it entirely rather than attempting to splice into it. Thirdly, determine the ampacity of the existing wiring and ensure that the new wiring is of equal or greater ampacity. This is crucial for preventing overheating and potential fire hazards. Refer to the National Electrical Code, specifically Table 310.15 for ampacity ratings based on wire gauge and insulation type. Fourthly, use appropriate wiring methods for the application. In residential wiring, non-metallic sheath cable, also known as an M cable or Romex, is commonly used for branch circuits. Ensure that the cable is properly sized for the intended load and is suitable for the environment in which it will be installed. Fifthly, make all electrical connections inside approved junction boxes. Junction boxes provide a safe and secure enclosure for splices and terminations, protecting them from physical damage and preventing accidental contact. The junction boxes must remain accessible, so avoid concealing them behind walls or ceilings without proper access panels. Sixthly, use proper splicing techniques. Wire connectors, such as wire nuts or twist-on connectors, are commonly used for splicing wires together. Ensure that the connectors are properly sized for the gauge and number of wires being spliced and that they are installed according to the manufacturer's instructions. Alternatively, consider using terminal blocks or other approved splicing methods for a more secure and reliable connection. Seventhly, maintain proper grounding. The grounding system is essential for safety, providing a path for fault current to return to the source and trip the circuit breaker. Ensure that all metal enclosures, such as junction boxes and appliance housings, are properly grounded. Connect the grounding conductor, typically a bare copper wire or a green insulated wire, to the grounding terminal in the junction box and to the grounding electrode system of the building. Eighthly, protect wiring from physical damage. Run wiring through walls, ceilings, and floors in a manner that protects it from nails, screws, and other potential hazards. Use cable staples or straps to secure wiring to framing members, ensuring that the wiring is not pinched or damaged. Ninthly, follow local electrical codes and regulations. Electrical codes vary from jurisdiction to jurisdiction, so it is important to be familiar with the specific requirements in your area. Consult with a licensed electrician or electrical inspector if you have any questions or concerns. Tenthly, consider the use of arc fault circuit interrupters, also known as FSIs, and ground fault circuit interrupters, also known as GFCIs. FSIs are designed to detect arc faults, which are a common cause of electrical fires, and GFCIs are designed to protect against ground faults, which can cause electric shock. FSIs are typically required in bedrooms and other living areas, while GFCIs are typically required in bathrooms, kitchens, and outdoor locations. 11thly, properly label all circuits. Use a circuit directory to identify the purpose of each circuit breaker in the electrical panel. This will make it easier to troubleshoot problems in the future and will help prevent accidental shutoffs. 12thly, ensure proper wire management within the junction box. Neatly arrange the wires inside the junction box to avoid overcrowding and to make it easier to access the connections. Use cable ties or other means to bundle the wires together and keep them out of the way. 13thly, inspect the completed work. Before energizing the circuit, carefully inspect all connections and wiring to ensure that they are properly installed and secure. Look for any signs of damage or potential hazards. 14thly, test the circuit. Once you are satisfied that the work is complete and safe, energize the circuit and test it to ensure that it is functioning properly. Use a multimeter to verify that the voltage and current are within the expected ranges. 15thly, Document the work. Keep a record of all electrical work that you have performed, including the date, location, and description of the work. This will be helpful for future maintenance and repairs and will also provide documentation for insurance purposes. 16thly, when transitioning from old to new wiring, consider the age and condition of the existing electrical panel. If the panel is old or outdated, it may be necessary to replace it with a new panel that is capable of handling the increased electrical load of the remodeled area. 17thly, be aware of the potential for asbestos in older wiring. Asbestos was commonly used as insulation in electrical wiring prior to the 1980s. If you suspect that the wiring contains asbestos, do not disturb it. Contact a qualified asbestos abatement contractor to safely remove the asbestos-containing materials. 18thly, consider the use of surge protection devices. Surge protection devices can protect sensitive electronic equipment from damage caused by power surges. Install surge protection devices at the electrical panel and at individual outlets to provide comprehensive surge protection. 19thly, ensure that all electrical work is performed by a qualified and licensed electrician. The electrical work can be dangerous and should only be performed by someone who is properly trained and experienced. Hiring a licensed electrician will ensure that the work is done safely and in accordance with all applicable codes and regulations. 20thly, when adding new circuits, be sure to calculate the load requirements accurately. This will ensure that the electrical panel is not overloaded and that the new circuits can handle the intended load. Consult with a licensed electrician to determine the appropriate size and type of circuit breaker for the new circuits. 21stly, consider the use of smart home technology. Smart home technology can provide enhanced control and convenience for your electrical system. Consider installing smart switches, outlets, and lighting controls to automate and optimize your home's electrical usage. 22ndly, be aware of the potential for hidden wiring. When working on a remodel, it is possible to encounter hidden wiring that was not properly documented. Use caution when cutting into walls or ceilings and be prepared to reroute or repair any hidden wiring that you encounter. 23rdly, consider the use of conduit. Conduit is a metal or plastic tubing that is used to protect electrical wiring. Conduit can be used to run wiring through walls, ceilings, and floors in a safe and organized manner. 24thly, ensure that all electrical boxes are properly secured to the building structure. Electrical boxes should be securely mounted to studs, joists, or other structural members to prevent them from becoming loose or detached. 25thly, when working with aluminum wiring, use special connectors and techniques to prevent corrosion. Aluminum wiring is more prone to corrosion than copper wiring, so it is important to use connectors and techniques that are specifically designed for aluminum wiring. 26thly, consider the use of energy-efficient lighting. Energy-efficient lighting, such as light-emitting diode, also known as LED lighting, can save energy and reduce your electricity bill. Consider replacing old incandescent light bulbs with energy-efficient LED bulbs. 27thly, be aware of the potential for electromagnetic interference, also known as EMI. Electrical wiring can generate electromagnetic interference, which can interfere with the operation of electronic devices. Use shielded cable and other techniques to minimize EMI. 28thly, consider the use of a whole house generator. A whole house generator can provide backup power in the event of a power outage. Consider installing a whole house generator to ensure that your home remains powered during a power outage. 29thly, ensure that all electrical work is properly inspected by a qualified electrical inspector. An electrical inspection will ensure that the work is done safely and in accordance with all applicable codes and regulations. 30thly, always prioritize safety when working with electricity. Electricity is dangerous and can cause serious injury or death. If you are not comfortable working with electricity, hire a qualified and licensed electrician to perform the work. 31stly, understand that wire gauge is critical. The American wire gauge, also known as a WG system, is used to specify the diameter of electrical conductors. A lower AWG number indicates a thicker wire, which can carry more current. Select the appropriate wire gauge based on the ampacity requirements of the circuit. 32ndly, recognize the importance of insulation type. Different types of insulation are used for electrical wiring, each with its own temperature rating and resistance to moisture and chemicals. Common insulation types include thermoplastic high heat resistant nylon, also known as THHN, thermoplastic with water resistant nylon, also known as THWN, and cross-linked polyethylene, also known as XLPE. Select the appropriate insulation type based on the environmental conditions in which the wiring will be installed. 33rdly, be aware of voltage drop. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause lights to dim and appliances to malfunction. Minimize voltage drop by using the correct wire gauge and keeping circuit lengths as short as possible. 34thly, understand the concept of impedance. Impedance is the opposition to the flow of alternating current in an electrical circuit. Impedance is affected by resistance, inductance, and capacitance. Minimize impedance to ensure efficient power delivery. 35thly, be familiar with the different types of electrical boxes. Electrical boxes are available in a variety of shapes and sizes, each designed for specific applications. Common types of electrical boxes include octagon boxes, round boxes, square boxes, and gang boxes. Select the appropriate type of electrical box based on the wiring configuration and the mounting location. 36thly, understand the purpose of knockouts. Knockouts are pre-punched holes in electrical boxes that allow for the entry of wiring. Knockouts can be removed using a screwdriver or a pair of pliers. Select the appropriate size and number of knockouts based on the wiring requirements. 37thly, be familiar with the different types of conduit fittings. Conduit fittings are used to connect sections of conduit together and to connect conduit to electrical boxes. Common types of conduit fittings include couplings, elbows, and connectors. Select the appropriate type of conduit fitting based on the conduit material and the installation requirements. 38thly, understand the purpose of grounding electrodes. Grounding electrodes are used to connect the grounding system to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. Install grounding electrodes in accordance with the National Electrical Code to ensure proper grounding. 39thly, be familiar with the different types of circuit breakers. Circuit breakers are used to protect electrical circuits from overcurrents. Common types of circuit breakers include thermal-magnetic circuit breakers, electronic circuit breakers, and ground fault circuit interrupters. Select the appropriate type of circuit breaker based on the circuit requirements and the electrical code. 40thly, understand the purpose of overcurrent protection. Overcurrent protection is used to protect electrical wiring and equipment from damage caused by excessive current flow. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. Follow these guidelines to ensure a safe and code-compliant electrical system in your remodeling project.